In this video we're going to look at putting state symbols into equations. Now there are 4 state symbols that you need to be familiar with. You know from Key Stage 3 and Key Stage 4 about states of matter: solid, liquid, gas. Okay, so basically what state symbols do is they tell the person who's reading the equation whether these things are solids, liquids or gases. The next state symbol that you need to be familiar with is AQ, which means aqueous, which essentially means that this thing is soluble in water. Okay, now if I give you a typical example of an equation, okay, so make sure you've either noted these down, guys, or you have a copy of them somewhere, okay, before you go on, because you will need these to do the questions that will follow. Okay, so if I just give you, I just write out a balanced symbol equation with state symbols in it, and you can use those to see how these things should actually look in a chemical equation. So we'll say the examiner said that you are reacting solid sodium carbonate with hydrochloric acid, and the products that you will get there will be, hopefully most of you know these, will be a solution of sodium chloride. You'll produce carbon dioxide and you'll produce water. Okay, so that has covered really in one equation all our state symbols. The examiner told us that the sodium carbonate was a solid, so therefore it is indeed S. Hydrochloric acid, all acids only behave as acids when they're in solution and dissolved in water, so aqueous. Sodium chloride, you might say, well, I see sodium chloride in my salt shaker every day and it is not dissolved in water. Well, this reaction mixture, if you like, here, okay, we're taking the acid, which is in lots of water, and we are putting into it some sodium carbonate solid. Okay, so in other words, we've lots and lots of water here. So how do we know the sodium chloride is therefore going to be aqueous? Well, you must use these tables of solubility on the reverse of your periodic table in what the examiner will call your data sheet. So how do we know that sodium is soluble? Sodium chloride, sorry, is soluble. Well, the table says soluble, water soluble. All sodium, potassium and ammonium salts are soluble. So sodium chloride is a sodium salt, of course, so therefore it must be soluble. We can double check it by saying most chlorides or bromides and iodides are soluble, so except silver and lead. Well, we're not talking about silver and lead chloride, we're talking about sodium chloride, so therefore it is indeed soluble. Okay, so therefore it goes AQ. Carbon dioxide, well, hopefully you know it's a gas. And water, you might say, well, why is that not aqueous? Well, aqueous means dissolved in water, and water doesn't dissolve in water, so it's a pure liquid L. That's an L at the end for our water. Okay, so I'll do a few of these. Again, please, if you think you've got the knack of it, please just press the pause button, have a go at them, and then come back and check my answer. Okay. So we'll start off with silver nitrate reacting with hydrobromic acid. Oops, giving the game away. To give us silver bromide and nitric acid. Okay, so let's get our solubility table and do silver nitrate first of all. Well, okay, let's look. Soluble, all nitrates. Well, that's easy. That must be aqueous. Hydrogen nitrate, which is nitric acid, and anyway, all acids are aqueous. They have to be. Okay. HBr. HBr is most bromides except silver and lead. Well, HBr is hydrogen bromide, so again. Okay. Silver bromide. Let's have a look. Most bromides are soluble except silver bromide, so therefore solid. Okay, very simple. Moving on to the next one, we have zinc plus copper sulfate to go to zinc sulfate plus copper. Right, let's look for zinc. Well, you will not find zinc on this table. It's a table about solubility in cold water of common salts, hydroxides and oxides. Well, zinc is not a salt, zinc is a metal. Now goodness me, if you don't know that metals are solid, you're in a world of bother. Zinc is indeed a solid. Okay, we can do copper sulfate from the table. Okay, let's have a look. Most sulfates are soluble except lead and barium. Well, that's neither lead nor barium, so it's aqueous. Zinc is another sulfate, it's not lead or barium. Copper is a metal, it's not soluble, it's used in water pipes. There we go. Simple as that. Okay, let's have a look at another one. We're going to do barium chloride reacting with sodium sulfate. And that's going to give me barium sulfate and some sodium chloride. Okay, so let's have a look at barium chloride. Maybe some of you remember already that most chlorides are soluble except silver and lead. Well, that's not barium, so therefore barium chloride is soluble. Sulfates, most sulfates except lead and barium sulfate. Well, that's sodium sulfate, so it's okay. Going back to our sulfates, except lead and barium are soluble. Well, there's barium sulfate, so it's insoluble. In other words, it's a solid. The examiner might write, if it's a written question, they might write a precipitate of barium sulfate, and a precipitate means it has to be solid. S. And sodium chloride here, well, it tells me that all sodium salts are soluble. We've already had sodium chloride anyway, so it's aqueous. And it's just, there you go. Very, very quick and pretty simple, guys. Okay, let's take another one. We will have a little look at nitric acid. So that's nitric acid, HNO3, state symbol, reacting with ammonium hydroxide to give me ammonium nitrate. Okay, plus water. Alright, so let's do nitric acid first, or hydrogen nitrate if you want. So all nitrates are soluble. Okay, anyway, it's an acid, so it's soluble. Ammonium hydroxide, all ammonium salts are soluble, so ammonium hydroxide must be soluble and ammonium nitrate must be soluble. Water, remember, is liquid. That's it, done. Okay, right, let's have a look this time at magnesium's metal plus sulfuric acid gives me magnesium sulfate plus hydrogen gas. Right, well, magnesium is a pure metal, so it must be solid. Sulfuric acid, okay, is indeed hydrogen sulfate. Sulfuric acid, by definition, if it's an acid, it's dissolved. Magnesium sulfate, let's go to our table. Okay, most sulfates except lead and barium. Okay, so therefore that is indeed aqueous, and hydrogen is of course a gas. Okay. Okay, we'll take one last go here, guys. We'll take calcium hydroxide. So we've got CaOH2 plus sulfuric acid. It's going to give us calcium sulfate plus water. Right, hopefully we're all able to pop in liquid beside water now. I shouldn't have to keep going with that. Calcium hydroxide. Okay, hydroxides, are they or are they not soluble? So if we go down here, most hydroxides are insoluble, except sodium, potassium and ammonium. So calcium hydroxide is insoluble. Okay, with sulfuric acid, by definition acid. Calcium sulfate here, calcium sulfate is slightly soluble, so we're probably going to write S there, and that's it done. Okay. Right. So, hopefully guys, that is a good insight into how you use these tables. That's, I suppose, the most important thing. They may ask you just, is this particular compound soluble or insoluble, and then they may ask you to write a full equation, and from that equation put state symbols, and you will have to refer to this. You'll also have to draw upon knowledge from lots of other areas, for example the fact that acids are aqueous, metal hydroxides, that if they say tell you are an alkali, are also aqueous. Okay, hope that helped.